There are three ways that you can add audit tables or change logs to your database design. One of the options is better than the other two, and I'll explain why. The first option is often called live history or row versioning. Any changes made to a row in the table are added as a new record into that table. Let's say we have this product table that has an ID, a name, a description, and a price. To capture the history of changes, we need to add a few fields. First, we'll add a username field that captures the user who created the record. Next, we'll add a version datetime field that captures when the record was created. This captures who made the change and when it was made, but we don't yet know what was changed. In this design, changes to the data are made by adding a new row that represents the updated data. So if a price is updated, rather than updating the existing row, we insert a new row with the updated data and leave the old row unchanged. To do this, we need to have some kind of version or revision number. We'll add a column called version number, which will be incremented each time a change is made. Let's see some sample data. If we insert a new product, then a new row is inserted with a version number of 1. If we make an update to one of these fields, then a new row is inserted into the table with a different version number, date time, and username. If we delete a row, then what happens? We don't want to delete data from the table, but we need a way to indicate the row is no longer valid or needed. A good way to do this is using a technique called a soft delete. This involves adding an active column to the table and using a value of 1 for active rows and 0 for deleted rows. Here is our updated table design with the isActive column. If we insert or update data, the isActive column is 1 because it's an active row. If we delete a row, a new row is inserted with an isActive of 0, indicating it is deleted. The main advantage of this design is that no additional tables are needed. You can just add a few columns to each of the tables that you want to audit. There are a few disadvantages to this approach. First, to see the recent data, you'll need to write your queries to find the latest version number for each record and to exclude inactive rows. This could be done by creating a view, but the query may get complex and you'll have to consider the performance with large tables. You'll have to use a primary key with multiple columns or a surrogate primary key to uniquely identify a row. This is because the same entry can exist multiple times. This also means you can't use foreign keys to this table, meaning you can't enforce referential integrity, which is a major benefit of a relational database. This can cause issues with your data quality. All three of these options will need to implement some code to perform the audit functionality. In this option, this code will need to enforce the insert-only approach. Let's look at option 2. The next option is called a shadow history. This is where you make a copy of the main table you want to audit and store the historic data in the audit table. With our product table, we can implement this by adding a username column to indicate who made the change and an update date time to indicate when the row was changed. We have a second table to store the history of changes. We can call it product audit or audit product or something similar. If you're doing this for many tables, I would suggest being consistent with your naming. This table has all of the same columns as the original table, including the username and update date time. There are no constraints on this table. Let's see some sample operations and how the data would be handled. If we insert a row into the table, it only gets added to the main product table. No data has changed yet, so we don't need to add it to the audit table. If we update the record, such as changing the price, then the original record gets added as a new row into the audit table. The updates are made to the data in the main table. If we delete a record from the table, the data is removed from the main table. Before the delete happens, the row that will be deleted is inserted into the audit table. This means we have a record of the row even though it was deleted. There are a few advantages to this approach. First, the performance of selecting only live records is unchanged. Because the historic data is in a separate table, there is less data to select compared to option 1 with all the data in one table. You can also manage historical records easily, as they are in separate tables. If you need to migrate data, you can do it from this one table. There are a couple of disadvantages. You have to combine two tables in a query if you want to see what data has changed over time. This could be done with a union all keyword. Another disadvantage is that whenever you change the original table structure, you'll need to change the audit table structure as well. This means an additional step in your process. Let's look at the final option. Option 3 is called a generic audit table. It's where you create one table to store all of the history for all auditable tables in the database. Here's what it would look like. We've got our product table here with some fields. To create a generic audit table, we'll add a new table called General Audit. This will record the changes made to all tables in the database, not just the product table. It's flexible, but we need to handle a wide range of data. We'll add a table name column to record the name of the table where the data was changed. We'll add a column called Field to record the name of the column in the table that was changed. We can add an old value field to record the value before the change, and a new value field to record the value after the change. We'll add a username column to record who made the change, and an update date time to record when the change was made. To capture deleted rows, we could use the same soft delete concept from option 1, where we add an isActive column to this audit table. When a record is updated, it remains as 1, but when a record is deleted, it is set to 0. If we insert data into the product table, the data goes into the product table. Nothing is added to the audit table. If we update data in the product table, the data is changed in the product table. We also insert a new row into the general audit table with the changes. If multiple values are updated, we would expect to see multiple rows in the audit table, one for each field. If we delete a row from the product table, it's removed from the product table. We also insert rows into the audit table to indicate it has been deleted. The main advantage to this design is that only one table is needed. You can have a single audit table for the whole database, which other tables can then use as their audit table. One disadvantage is that the old value and new value columns need to cater for every possible type of data change in your database. This often means they need to be large varchar fields, even if the data being changed is numeric or date. This will involve logic to convert data types in the code that performs the auditing. Also, it's harder to view the history of a record or recreate a record at a point in time. Depending on your need to do this, it may not be much of an issue. Out of the 3 options, my recommendation is option 2, the shadow history approach. It's easy to see how the data has changed for a record over time, and it doesn't affect the performance of viewing live data. I've read concerns about the number of tables needed for this approach, and how it can clutter your schema or increase the maintenance effort. I feel those points are symptoms of the real issues. What does a cluttered schema mean? Too many items in your IDE table browser? If so, you can filter them or ignore them. Too many options appear in autocomplete when you write a query? Consider renaming the tables so they don't appear. Too hard to maintain or document? Improve your maintenance or documentation process. I think the disadvantages of this shadow history approach are minor, and the advantages show it's much better than the other options. I hope you found this video useful. What do you think about these audit table designs, and what is your preferred option? Let me know in the comments below. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you like this video, consider subscribing to my channel. Thanks for watching.